Hello, class.
Hello.
Yeah, and everybody else log in. 10 people. Hmm. Everybody sign the roll.
I have not yet. Can you repeat what the link for the roll was?
Go to the syl9.com website and then click on the CSCI 194. And then at the bottom of that page, you'll see register/sign roll. But you click on that link and then you go to student utilities and then sign the roll. Because you should have if you have you should have went through a registration process in that website before you sign the roll. And there's a how-to video on going through those processes for
Okay, so Mr. Sylvester.
Yes, ma'am.
How come when I go in to join the meeting on Zoom, it tells me that I need to register?
You need to register.
And I click the button and it brings me up to Zoom. Every time I join, it tells me that I have to register, and I done did that already.
Let me ask you, I think, did I set it? I thought I set it to register one time. I don't know.
And I got out of it and I came back and I clicked join and it told me again that I need to register.
It did me that too.
I know it should have asked you maybe one time to register. Every time you log in?
Yep. Every time I join. When I come in to join, it tells me that I have to register. And
registration is doing what?
It's just, it fills your name and your email address and that kind of stuff.
Oh, yeah. And I think what happened, I think I chose that option, but I thought it was going to do it one time because they had told us, I think last semester or the end of last semester, how they had people hacking into Zoom meetings and whatever. But yeah, that could be annoying too at times. But
I mean, sometimes, and that's why I think on the screen you see where it has my name, Darla EBR Schools.
That's what you log in with?
No, that's what's pre-filled when it tells me that I need to register. And I tried to delete that EBR on there, but when I deleted and I went out and I came back in, it brought up that same thing.
That same thing. Because the only thing I can see is you have a Zoom account registered independent from Zoom itself. You know, from within the Zoom within Canvas, and it's going to that Zoom account. You understand that's the only thing I can see with that.
It's giving me problems too.
What is doing?
I registered and then I went to sign the roll, and it told me that the class ID is not found.
Okay,
I go back to register, and then I try to register like with the same ID, and it says the ID is already taken. So it's not found and it's taken.
Okay, now what's the ID though?
9715.
No. First initial, last 4 digits dash, and I think this is one. That's it. Right, yeah, that's your login ID for that. Right. But I think she's talking about Canvas. You're talking about the role, right?
Right.
Right, but because you should have gotten an email with your login and password when you did the registration.
True.
Mm,
And sometime I think I don't know if I put a forgot password in there. I mean, yeah, I forgot log.
Well, on the registration screen, it just says last 4 digits. It doesn't say first
Right,
initial, last
that
initial.
right. But what it did, if you look to the right of it, it say last 4 digits. And what it does, it generates an ID from all the information you give. You understand what I'm saying? It pulls your first initial, pull your last initial, pull the section number, and those 4 numbers, and then it emails you your login information. You know what I'm saying? With your password. Right. So, and I might could change that. Because see, if I change it from ID, you know what I'm saying? Because it's not actually your login ID. It's like your school ID, the last 4 digits of your ID number. You know what I'm saying? And if I change that, then people are going to say, well, what 4 numbers to put in, you know? So that's why it says last 4 digits of your ID. But then what happens, it creates a user login for this particular to sign the role.
Okay.
What it did.
I'm looking back on the email that I first got when I
Okay, but it should be your first initial, your last initial, those
Okay,
last 4 digits, dash, and I think this is section 1, -1. Not
well, it gave me -3. I thought this was -1 too, but it's not.
No, you must have put -3. I tell you what, go to student utilities. It's showing it was dash. That's a new email though. That's a current email.
Hey, there we go. Okay.
Oh, you got it. But
well, no, my connection came back is all.
Oh, okay. So go to student utilities.
All right.
And it should have something about update. Don't have nothing about update.
Update student information. All right.
See if you can update the section. Does it allow you to update the section?
Let me see here.
Probably not. Did it allow you? Let's see something.
It's not allowing me to log in the first place.
The first initial, last 4 digits, dash. Let's see something.
I'm getting nothing.
Nothing at all.
And it just says password not found. Please try again. I'm just checking the email. I'm entering the exact password I was given.
But now you're typing in -4?
-3 is what it had me as. That's what the email says.
Oh, that you're doing the -3?
Mm-hmm.
Okay, let's see. Let me see something right quick. Then we'll get with class.
Now it's taking the password, but now it says class ID not found. Even though I'm typing JD9715-3.
Yeah, dash, not the underscore, but the dash. Yeah.
9715. Let's try that. Nope, class ID still not found.
Okay, let me see something.
5-1. Password not found.
You in the 1943?
Yeah,
Yes.
that's another issue people have. Let's see something.
I can see up at the top left it says 194. So9.com/194-PHP/PHP files.
All right. Let's see. What's your name?
Joseph Dixon.
Dixon. Okay, let me see something. Edit Mr. Dixon. Okay, Mr. Dixon. No, it's -1. You got
there?
JD 9715-1.
It's when I try -1, it says the ID is not found.
JD 9715-1.
Okay, let me try.
And you know your password, 420. Password, I'll just give you like the first let's see, TR and then M1. The first three and the first two and the last two. So
Yeah.
did it go through?
M1. Okay.
Pressure.
It's not going through. I don't know if I'm
What it give you?
maybe I got the wrong version of it.
But what I'm saying, what message it give you?
There we go. Okay, great. All right.
Oh, and it's slow. Okay. All right. So it went through with -1, right?
Yeah. Now let me go to student utilities. Let me try signing the role with that.
With what? Oh, but what you did just now?
Let's see.
I think you register, huh?
No, that was the edit information, but I didn't have any information to edit because it took it at -1.
Oh, okay. All right. Okay.
Let's try.
Some of the students had a problem with
There we go.
keeping.
All right.
They had their old login from like last semester saved on their computer, and so
Oh, right. In the
log in.
cache, the cache memory. Yeah.
That's
So why you can't use the one from last semester?
You're in a new class. You're in a different class.
Oh, okay.
Yeah. Now you could use the same login. You know, you're given the same information, but you're in a different classroom. You know what I'm saying? But what happens, like Mr. Gaddy say, is like many times you might have cache memory and you think you're on the right class page, but you're not, because most of my software look the same. And when you're trying to sign the role, you're not in the right time. Yeah, so you gotta watch those things. All right. Now, anybody with any other little issues or whatnot? The assignments. Some people didn't turn the assignments in. Some people turned the assignments in, and some people had some issues with some of the assignments. Who that was, Mr. What is his name? Sawan. See, I don't see him on here. But I think he had contacted me and asked me, Mrs. Sylvester, why I made XYZ on the assignment. Normally when I grade the assignments, I'll put a comment in the comment box of the assignment. So you'd have to go back to the assignment and then look at the comment.
Okay,
right?
Mr. Sylvester.
Yes, ma'am.
I think I got mine backwards.
I don't know what you was doing, Miss Bradford. I think I know for sure on the second assignment, you was doing something with bubble sorts and whatever. I'm like, we didn't even get to that. That's the next chapter. So I'm like, what is she doing?
Okay, you talking about the project 1 and 2, bonus 1 and 2?
Right.
But I did the arrays. I thought that was arrays. What, I mean, I don't know.
Yeah, array. Well, one was array and one was vectors.
And I think I did, I don't know. I thought I did it right. Because it was
want me to pull them up?
Yeah, please, because I'm not understanding.
All right, okay. So what I'll do, Claire, let me share my screen. And anybody, like I say, you can look at it and see if you got questions. Now, the assignment was, the first one, was to write a program that will pass that will call an array, will pass an entire array,
right,
2 different arrays, to a function and print the results. But the array should have been initialized. So the idea was to have one function Then you pass the first array and print it, return back, pass the second array and print it. All right. So let me go to your program. Let's see. Okay, I want to share. I'm gonna share screen. All right. So I'll share my screen and do share. All right. So here, if I go into this, get in here, and I'll go to the assignment. Go to grade and okay, let's see. Let's see where we are. Not there. I went, oh, did I go too far? I think so. Here we go. The first assignment. All right.
I'm right under, right there.
Bradford. All right. The first one is a 0. All right. Let's look at that one. Let's see if you turned it in or whatnot. Did I click on it? Did I click? Okay. There we go. All right. Oh, here we go. Speed grade. So here we go. Ms. Bradford has a program, and I got program errors. Yeah. Now this here, the header file, it looks great. You understand? Everything just by looking at it, you know. And normally, I'll look at this one, see if everything is in order, but I'll have my own header file. But sometimes I'll find, well, oh, wait a minute, what is this? This is wrong. But looking at this, you got your you're loading your IO stream because you're doing CSCI outs. You got the user namespace, the standard libraries, you know, it's gonna print. Then you got void head, which is your function header, not main, no semicolon. Then you got open curly brace, close curly brace. That's your body for your function. But then you got C out, semicolon, where you're streaming, semicolon. See out, stream this, double quotes, stream, semicolon, or inline semicolon. So all this looks correct, okay? So, but some people even submitted their header files, but in the program, they never call the header function, okay? So if you looked at your assignment, I put that in there. So here, Ms. Bradford, I got program errors. So when I go here, when I look at this, well, no, that's the header file, the .cpp file. I could look at it, but what I do, I take it and I load it into Visual Studio. So looking at this, like I say, I can just look at it, but I'm gonna actually take it and put it in there. So, but just looking at it off top, you passing the two arrays, so you're passing them both at the same time. And then you're trying to print one and then print the other, all right? So with the naked eye looking at it, you can say, okay, well, it's okay. So let's do this. Let's take, I need to open up Visual. Let me see something. I'll do that. Open up Visual. Y'all can see my screen, right?
Yes, sir.
Okay. Okay, so what I'll do, I'll drag this to this house, and I'll take this. So what I normally do, I'm gonna call homework that I use for most of my classes, and it have my header file set up or whatever. So I have it's gonna come up. Okay, so here it is, and then I'm gonna need to drag this down too. All right. What this say? I don't know what this is. I'll click OK. All right. So here I have. I'm gonna click on. I'm gonna download this program. Download this one. It should come up in here. So this is your program. Control A, and I'll go put it in source. All right. So here now. In this program. So, you know, looking at it.
This is what I did?
Yeah.
Okay.
This
It
your
didn't
program.
show me any of that. It didn't show me any errors. So I don't know. I'm just confused on it.
All right.
Okay, go ahead.
Let's see. Let's look at it. Okay, you got void, a display, arrays, int. Okay, you got array 1, array 2. So arrays, display, arrays. Now look at this. First of all, when you look at this, you got an error here. Why? Because after void, you should give the name of the function. Now, a function name should, what's the name, what's the characteristics of a variable? A user-defined variable should be one word, right? So you got display space arrays. You got what I'm saying?
Yeah.
So that's 2 words. So number one, that throws out the what? Valid name. You got me?
Yeah.
Now, if to make this work, we could take displays off because you just use arrays all in the program. You understand?
Yeah.
Now, that should take arrays off, but then, well, yeah, then you got to take display arrays off here. But you could, I could have put the underscore in there too and put the underscore everywhere also. You got what I'm saying? The name has to be the same. So I'll remove that. Okay. And then I'll remove this one here. Let's see. Display array. So you were somewhat on the right track, but it was like, that's just one part. Okay. And then this is outside of anything. So you got all these curly braces here. Okay, this open, this closed, but then you got all this outside of anything. So that's other errors. You got what I'm saying? But then look here. Look what you did here. Int array space 1. Array 1 should be a what? A user identifier or a variable. So the name of this array can't be user space 1. It could be user underscore 1. Not user, array underscore 1, array 1, array 2. You understand what I'm saying?
Yeah.
No spaces. The spaces matter in computer science. They really do, and see here, and see, and that done cleared out those errors. You got me? But then still, we got arrays here. Why is arrays? Look, we got arrays here. Arrays here, arrays. Let's see what here. Let's take this out. Well, this gonna print out in. This print out in, but this should be inside. If I'm gonna print out all of them, this should be in here. And then I got curly brace, and this is a function. So I should have one closed curly brace. You understand?
Yeah.
Right. So what? Well, let's look at our main function. Where's our main function? We don't even have a main function. All right. Oh, well, okay, we do. So we got open curly brace, closed curly brace. But okay, this is this. You got open curly brace. Oh, look, this closed curly brace. Okay, that's for that. Here, if you're gonna do this for, no, you don't have one. Okay.
But shouldn't that open go over the void?
No, it don't
That's
have
right.
to. No, look what you did. You put a semicolon.
Oh.
See here? The semicolon. So you know what I'm saying? Stuff like that, man, that it does matter. All that does matter. Yeah. So it's like you're gonna have to train your brain. Okay, if I'm defining a function header, no semicolon, opening the beginning of the body, the ending of the body, and then all my statement goes in here. I can have 15 closed curly braces, but I should have 15 open curly braces. You understand what I'm saying? They should match within that function.
Right.
Yeah, you got me? Yeah.
Can you widen that screen and let me take a picture of it?
Okay, let's run it though. But now, This one, the way you wrote this one, you passed both of them at the same time. I would have accepted that. That wouldn't have been no problem. But the thing was, if you want to write a more efficient program,
Right.
see where you have the number 10? see where you have the number 5? What you could have done was declared a constant value for 10 and a variable for 10 and 5. And when you pass your array, you only pass one array and pass the size declarator with that array. So what you do, when you call you're gonna call the function twice. So when you call the function the first time, you're gonna pass array 1, and then you're gonna pass the size declarator, which could be I, and I could be 10. And then it'll do this from N through I, which I is 10. You return back, you pass the second array, and it could be J, and J is 5. So you're passing array 2, and you're passing J. So this time J would be passed into a variable here, and then you'll do from N to whatever that J value, which is 5. So you understand what I'm saying? You're using that function, and you got variables assigned so that size and stuff change at each time you pass the function. I mean, pass the array. You got me?
Yeah.
Yeah. So let's run this though. Let's see what we get here. So if I do debug, I can't see the bottom. Let's see something. Okay. All right. So now look at this. You probably would have got points taken off here. Why? For the first one, look like it's printing the numbers without spaces. All right, so we'd have to just put spaces here. For the second one, look like it's printing the address. So let's see what's happening with the first one. All right. The first one, see here, you don't have space. So that'll put space in between the numbers. You got me? All right. Now with the second one, it looked like it might. No, is it negative? No, you don't have negative. So the second one going m equals 0, m less than 5. Let's see, you got A2, and then you yeah, well, that's m to 5. So let's see what numbers are being printed, but it's not representing the right numbers. You're passing A2. Well, let's see. You could do it that way. I don't know, but let's see what we have here. 1, 2, 3, 4, 5. Okay, your implicit list did it. That's right. Boy, where's your main at? Where's the main? Okay. You pass array 2. All right, so that's good. When you pass 2, it goes into this. Array 2 goes into here. Then you say for m equals 0, m less than 5, C out A2 sub m, and m starts at 0. So let's run it. Let's see what we get. Close this out. Let's run it. All right. Oh, that last number, there's something with the last number. So we got what? 1, and see, I probably took off this space here. Put a space. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's see if that's the 10 numbers. Okay, let's go back here. Yep. Well, nope. You got what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you got 11. So your array size was really 11, but I told you to do 10. So this array, you can have a large array and print only so many, as long as you're within the range. But see here, you implicitly define. But if I do something like this, I'm gonna get an error because what? I'm telling it my array size is 10, but I'm giving it 11 values. All right. But doing it this way, I'm telling the array whatever I have in here, this list, take that as the size. So you kind of looked up, or would have looked up on that part. All right. Yeah. And the second one, let's say 1, 2, 3. See what happened? How many you got? 1, 2, 3, 4. So what happened here is it gave you an address in the computer because there's no value to output. So if I come in here, because I'm printing 5, right? 0 through 4 is 5, excuse me. So if I put in, say, 83. So now when I run the program, I'll close this out, and now it should run properly. So you see how man, in computer science you gotta kind of go through it. And like I see here, 83, no
Okay,
error.
let me ask you, okay, with this here, when I
Uh-huh.
print, is this telling me that I have errors?
What
Because
you
when
mean?
I went to print, it did.
Yeah,
bring
down
the
here,
tab, but
down
I
here,
didn't-
down here to tell you at the bottom of the
Right.
environment, the IDE, it'll tell you down here when you have error. Like, let me show you. If I put in 10 here, remember, I got 11. But then when I go here, I have to build it. I have to do a compile. When I do a compile, okay, look, too many initializer values. So what? In line, what line it tell? It should tell me the line. I gotta open it up some more. Tell me line 14. So it's saying I got too many initializers. So it's saying, okay, I got this is 10, but then I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 10 and 11 not the same. So either I need to increase 10 to 11, or I need to go into my list and reduce that to 10. You know, to make that error go away. Is the program right? It depends on what the instructor wanted or the user wanted. You know, did they want 11 or did they want 10? You got what I'm saying?
Yeah.
So that you can't just say, okay, I fixed the problem. No, did you fix it to where the program is going to work properly? All right. Because anybody can just take the errors out, but then you take them out so it'll work. So that's what you got to look at. You got to kind of look at the error messages. You know, you got to go to the build and do the compile every time you make changes, right? And that would then it'll show you error. Now, if you don't get this down here, normally what you would do is go to Windows and do a reset Windows layout. And what that'll do, it'll ask you if you want to go back to the default, yes, and then it's gonna allow you to have that menu at the bottom. All right, so you can. I think I got my screen in front of it. Right, you'd have that menu at the bottom. When I do a compile, it'll give me my error. So when I close that. When I do a build, it's gonna give me my errors. And see, I got this. See here. So see how it give me my errors down here.
Yeah.
So it'll give me that default window where I know I have everything I need to run my program.
But I'm serious. When I went to
Did you compile that program?
It didn't
No?
bring me these errors. That's what I'm saying. That's why I'm confused. But
Did it give you any output?
No.
Oh yeah. Well, see, if you don't get output, definitely it's wrong. You know what I'm saying?
Wow.
If normally all of my programs, what I said, and I don't want to kind of confuse you, but all of my programs that I give, the sample output is the output. Now, some output later on going to be written to a file, but you should see output. When you see out in a program, you should see the output. So now, another thing, like I say, you didn't call, you got the header.h file, you got it loaded, you understand? Now, I didn't get the error here because I have a header.h file in here, all right? Where it is. I thought I did. Yeah, it's somewhere in here, but I got a header.h file loaded. Let me delete this. Yeah, see, I have one. So it didn't give me an error, right? So, but your header.h file, the function that you have in your header.h file is called head. So I know that I can do something like this. Being that you print this one time, I could put it here and it'll work. But if I were to call it twice, I could put it up here before I start initializing or right before I call the function. So all I would need to do is put in head, if I could type, and I'm calling that function that's gonna output what? Your name, the program, the teacher name, the date, and all that. right? But I created a dummy one, and I do that because I make it distinct, different, so different from whatever. So when I see it, I say, oh, they got it in there. Because if everybody's the same, sometimes I might overlook it and not notice that it's in there. So this is what happens. Oh well, I forgot what I did. Okay, take this out. Okay, run it. Okay.
It
All
took
right,
me
so-
all day to do this.
Right. So I see header info. So I know that what you call that function, but I'd have to see if you actually loaded the header file. So I'll examine the file first to see if you loaded the header file, and then I have to make sure that your header file matches head whatever, you know. And so if it's head, I know it'll pull up that particular header file, and then this is the results. Okay. But I would say, see, and like I say, computer programming it, you got to be particular. It's almost like giving somebody instructions to your home and putting it in a GPS. The more precise you are, the more likely that person's going to make it to their destination. You know, you can't just say, "Oh well, turn at the tree at the third oak tree," and turn, you know, do that. Then people, you know, they confused because you might have skipped a step. They might have counted not counted the number of trees right or whatever. So it's like when in programming, you got to give in coding, you know your logic got to be specific, but then in coding you got to be specific too, because we know what we can have those curly braces where we grouping off sections of if logic and whatever, and if we move a curly brace in the wrong place, we got 5 open and 5 closed curly braces, but we put one of the ending ones in the wrong place, it could totally throw our logic off. Okay, so it is very, very important that we follow those specifics. You got to know those little details in coding. And like I said, the next chapter, well, this chapter, when I give you these 2 programs, it's gonna be a headache. It'll be mind-boggling. You're gonna have to go through it, you know. And what I'll do, further action. If anybody have any other questions, and then after that, then I'll get into the next 2 assignments. Then we'll finish the chapter. You know,
I need to take a picture of that.
Oh, okay. Let me see if I can maximize it and make it a little bit bigger.
Mr. Sylvester,
Yes.
where do I go to get like chapter notes and all the
This
notes?
Miss Harrison, Miss what?
Bring it down.
What's your name?
Richardson.
Miss Richardson. Miss Richardson.
Uh-huh.
I want to ask this question.
Man,
down
I be
from Mississippi.
confused. I be confused and lost. I ain't learned. I'm confused. I don't know what to do.
You ain't turned nothing in.
I know. I tried it and I don't even know what I'm looking at no more.
Man.
I'm in the same boat.
All right,
Say that.
I'm looking at no more.
Mr. Whatever. All right, we talked about arrays, right?
Sir?
You look at arrays. Look at how arrays are set up. Look at how arrays are initialized. Look at how arrays are printed out. You understand?
A video or something that'll teach me how to put it together, because I
That
understand piece for piece and what I'm doing, but I don't understand how to put it together.
The program.
Did y'all read the chapter?
You have to read that book because I mean,
Yeah,
Yeah, the book's really
I
good.
made a lot of errors, but
Right. Yeah,
I was
right.
able to at least
Get
do
through
the,
some of it, right?
yeah.
Yeah.
Also,
You
they
have
have
to read that book. You
And
have
at the same time, you gotta fall back on those pseudocode skills.
yeah,
Because you got to what? Everything gotta be logically in order.
yeah.
Yeah. So now it's not the pseudocode, because you should have that down pat. Because you're given a problem, you should know how to solve it. But now you're getting more into programming to where they don't want me to just give the output. They want me to give the output by doing it a certain way. You know, so that's what we're getting into. You know what I'm saying? And that makes it a little bit harder. You know?
Can you scroll that down a little bit, please?
All right.
Okay, I'm done now. You can get out of it.
All right.
The same book from 1923.
Right. No.
It's the let me get
What?
it.
1933, yeah.
Yeah, that. Yeah.
Right. Now, the thing is, like I say, looking at arrays, if you look at my notes, I tried to pull certain things out, but then at the same time, like I say, you can go back to the notes. Now, if you look here,
It's the book.
right. If you look here, you got here is where the arrays are being what? What are being done at this point? Can you tell me? Huh?
Initializing how?
They're being declared and initialized, right?
Yeah.
Right.
What type data is being put into this array?
Yeah.
So now you understand where I'm coming from? Because you can have a string array, you could have a double array. You got me?
Right.
Right. So Ms. Richardson, you see how you got to put all that stuff into play? Like you can't just say, well, wait a minute, I just read something on int arrays. I don't know how to do double arrays. Yes, you do. Only thing different is what? Double have what? Double data types have what type data?
Decimal.
Decimal. That's the only difference. So you understand what I'm saying? So you're gonna have to kind of take some of your skills and put it into play, you know, because like I say, we went over this is int arrays, but like I say, you can have any data type, you can have an array of those data types. All right? But right now we could look. Go ahead.
You could also do it without initializing it if you really wanted to as well.
Right, but the assignment was to
Right,
what?
to initialize it, right.
Right. So you understand? So
Right.
all those things come into play.
But what I was saying is though is that you get to just go off what you see in this. You actually have to learn the logic behind it.
That's the key. Because what? We could have read this from a what? I could have told you what? Okay,
From
you
a book
did that.
or
Right,
took
input
it off
file.
a website or something, But you
Yeah,
gotta learn the logic.
or input file, right?
Right.
I could have
Right.
told you read it from the input file. And
Right.
then now you're like, oh, well, Mr. Sylvester, well, I don't really, but you can't do that. So here we initialize it, all right? These are the names of the array. Array 1, array 2. Looking at this, what did I say? What would be the size of this array? Well, really, we'd have to, I'm going to take this off. So it'll be what? 10. It'll be the number of elements. By default, it'll count this and it'll automatically assign 10. So you see how you got to be able to understand what's going on, right? This one, array 2 is the name. What's the size of that array? 5. You got me? So now that's initializing the array. It's called array 2, array 1. There's an integer data type. One is 10, one is 5. What's the content? This is the content of the first one. This is the content of the second one. Yeah. So now we know
at
that.
17, they're just passing the arrays to the function void arrays.
Correct. It's passing the arrays to that function called array 1 and array. She got it. Like I say, we're using the word array a lot, but array 1 and array 2 is being passed to the arrays function into what? Array 1 is being passed into what? Into what?
Array 1.
A1. See here?
Right.
See when in the main function when we call array 1 and array 2, they're in order. Now if I'd have swapped these and put A1 here, A2 here and A1 here, I could have got errors. Now I wouldn't have got errors in the first one because it just would have print 5. But I'd have got error right here. I'd have got an error because I'd have went beyond the 5. And right here would have just printed 5 if I'd have swapped the names in this order list. Because if I'd have swapped the names, if this was array 2 would have went into A1. You understand?
Right.
And what? A1 says we're going to do 10 and we would only have 5. So stuff like that. So array 1.
You didn't have to use A1 and A2, correct? Could you use one?
Right. Could I do just one?
Right, yeah.
Right. That's what I was saying. Let me do it in short. She could have done it this way, as I was telling her. And I have to change my argument list because what? I'm only passing one.
Why? I mean, you can do it in one.
Right. And I'm gonna take that also.
To me now.
Well, what I'm saying, watch. I'm gonna show you. And like I said, it all depends on your logic.
Yeah, it's all about the logic.
Right. And then I'm gonna do one here, and I'm gonna do let's do I'll do it like this, count, and I'll just do 10. I could have made it a variable, right? I could have made a constant, whatever, right? So I'll say 10 here, and then I'll do
array 10.
Right.
2, yeah.
Array, and then array 2, comma 5. Right. All right, and I'll explain what happened in here, and I'll do what? It's an int, right?
Right.
I'm passing an int. If I could type. All right, and then I have to go down here and say what? I have to give it a value, right? Int, and I could say, I'll just call it Z, all right? And then in here, I want to go to what? I don't want to go to 10 because I'm passing 10 into what? Z.
Z.
Right.
You're going to put the Z inside the array.
Right, and then I don't have to put it inside.
Oh, no, that's in. Yeah, you're right.
Right. And then here, I don't want to go to 5. I want to go to Z. All right. And then now, but also what? What's my array name each time I'm passed? Well, no, I need to take this out altogether.
Yeah.
Let's see. I need this and then this. All right. Because what? The first time through, when I pass array 1 and 10, okay, so I'm passing array 1 into A1, and I'm passing the 10. This is the time it's going to perform it. So A1 going all the way from 0 to 10. Then they're going to go say array 2. Array 2 going to be passed into A1, and then 5 going to be passed into Z, and I'm going to print the contents of A1, which is array 2 at this time, all the way up to Z, which is 5. So you see what happened, Miss Bradford? Yeah. And who was gonna say something?
I'll say yeah. So all you're doing is in line 14, you're passing those values from line 14 into the function.
Correct. And what you're doing, you're reducing your lines of code,
right?
And you're making it more efficient.
Right. And you're using your operator down there so that way it goes from 0 through 9.
Correct. Correct.
Putting that array.
Right. And when we run it, we're gonna get the exact same answer. So when I run it, what happened? What's going on here? Oh, he said, I got an exception error. Unable to start program. Why? Let's debug again. Let me bring this up.
I've actually had that issue as well with
Yeah, let me bring this up or something. Well, I need to close. I think I need to close this window, but still, it should have. Yeah, see, I had to close that window. All right, so now it looked bad. So let me do this. What I'll do right after the first one, I'll just do something out here. I'll do C out in line. All right. So now what? It print the first one, go to a new line, then it's gonna print the second. All right, return back and print the second. So when I do a run, all right. So see what happened? Same exact results, right, Ms. Bradford? But we reduced the lines of code, right? And now we passing using those values. The Z, 10 and 5 would pass in the Z, and that controlled the timing or the iteration of our loop. All right. So pretty much exact same out results. See, it kind of shortened the code, right? Shorten the code.
Yeah, but I'd rather do it the long way.
Well, doing it the long way is good to get a grasp of what is done. But I would say even if you wrote a program and it's always, even if you figure it's efficient, go back and look to see where you could tweak it to kind of reduce the size. Because we as programmers now we don't see it, but as you start working in a development environment, or you're developing software, you want to make your programs as efficient as possible. Because as you start building modules onto it and whatever, it can be very large. We could take up a whole lot of computer memory and whatever. And then depending on how much it takes up, people might not want to buy it, you know, because it's hogging the computer resources or whatnot.
You're also kind of fighting the purpose of.
What's that?
I said you're also fighting the purpose of C++. C++ is really designed.
Right. There you go. Yeah. Yeah, that's right. All right. So anybody have any other questions or comments or whatever?
Yeah, if you need more help too, they have the Cherno on YouTube, and he's really good at explaining things too. So
More what now?
What he said?
Cherno on YouTube. If you need more help, he's really good at explaining things as well.
Who that?
YouTube.
Cherno.
Okay. But he said a particular name, though, I think.
Wait, let me see. I think he got
It's
it on.
Cherno.
Okay. So yeah, he said you could go to YouTube, and I don't know the guy's name. You could go there at top and look him up. Yeah. But like I say, go ahead.
As far as Visual Studio goes, I can't. Can you? Is there any way you can send me a link to Visual 2010, because I think that's the one you want us to use. And
you can use 2017.
That's
Well,
the one I have. It wouldn't let me.
Well, the thing with 2017 though is that video that you had us watch on how to create and compile a C++ program.
Yeah, it's a little different.
Yeah, it's different, and I couldn't do the things that they were able to do.
Oh, okay. No, but what I didn't I post the lecture from last class? Because I think I went through the visual steps. Because remember, let me close this out.
I wasn't able to attend last week, so that's if you did.
No, you
that's
didn't.
fine.
I don't think you went through the steps, Mr. Sylvester, because I had a hard time trying to. Okay, when you go to Visual Studios, you have to create the file first.
Right. Yeah. Normally, you click create down here. Right.
Right.
You click the create, because the first time you load it, you might have it might, depending on if you load the entire package or whatever, you might have Python, Visual Basic, or whatever. But you want to make sure you at C++. All right. When you click on C++, you want to make sure you choose Windows Desktop. All right. And then you would choose the Windows Desktop Wizard. Okay. So Windows Desktop. And then Windows, because if I change this, I'll turn it on. But then, because if I choose different things here, it'll change. So I need to make sure it's Windows Desktop. Then the Windows Desktop Wizard. And then what happens here, you can give your program a name, you know, whatever. Well, let's see, let me choose desktop. All right, so now you can give your program a name. So I could say sample. All right, I don't know if I have one. I'll say sample 1. All right, so I give it a name, sample 1. Now, when I click OK, well, this is where it's going to store it. This is where it's going to create a folder for the file. And then sample 1 will be the folder. All right, and I click OK. Now, at this point, I would click empty project. You don't have to worry about any of the other choices. Just click empty project. And then you click OK. Once you do that, now you're in that blank or that empty environment that you normally be in.
Question: you can't click the console?
No.
You can't?
No, don't do that
That's
one.
what I was doing too.
Right. Because that one gonna bring in other files that support that particular program you're working with. But I want you to just have an independent C++ file. Right. So you could run it on almost any platform. All right. So now, once you do that, and if you look at my screen, remember I told you if you can't find this, you just simply go to Windows, go to Reset Layout, and click OK. And it's going to just set your layout to where you can see all your stuff. Then you right click on Source. And now we back to doing our adding, our whatever. And then we do C++. We can give it a name. This is our folder where it's going to be again, all right? And then sample 1. and click OK or add. And now we're at a blank program where,
Wait a
you know,
minute, go back again. You said you say Windows and up here at the top, Windows and what?
yeah, you right click here, source, add.
No. Go
What?
back
She's
from,
saying the Windows,
The Windows
reset thing.
desktop?
yeah.
Oh, no, you're talking about, yeah, you go to Windows
If it's
and you
blank.
go to reset Windows layout,
Reset.
window layout.
Okay.
And what that gonna do, that gonna give you those default windows so you can maneuver with that adding a a new CPP file or
When it brings up the file, I click on source file.
Right, you're right. So yeah, right click on source. You can add, or you can now if you have a file on your jump drive, you can do existing file and it'll bring it in too. All right. But then too, remember we said what? Our CPP file, our .h file, we could go to header or we could do source. It's gonna take us to the same place. Right click, add, new item, and like I say, .h, and we could give it a name, okay, and say add, and now we have our .h file, and this is our source file. So you can just tab in between the two. Both of those are in the same environment, so you know they'll work together. You have to not email, you have to submit both of them to me in order for me to look at them and work with them to see if they're working. You understand? So make sure you submit them both to me in the individual assignments. All right. But Mr. Gyro.
Yes, sir.
You got it now, or you still?
Yeah, I was able to pull up the 2017 version.
But you just couldn't configure that empty project.
Right, because that in the version I was using was apparently Visual Studio 2019.
Oh yeah, now 19 is kind of different. Yeah, it's totally different. It's more like it got a different kind of flow to it. And I use it once or twice, but I just stuck with this one, I used it before, but I redone my system and I didn't put it back on. I just did it with 17.
Right, and as I typed in Visual Studio, it showed that I also had 2017 installed. So I pulled up 2017 and I was able to do it from there.
Okay, yeah, all right then, yeah. All right. Anybody else with a question? All right. Now we did vectors. Some of y'all kind of got it and some was whatever. With vectors, what I told you about vectors. Vectors work different from arrays. Remember, vectors, they can grow or shrink. Unlike arrays, when you declare it, you have to give it a size. So with vectors, you can run the risk of having a vector defined to a certain size and then add to it and then print the first part, which is going to be 0. You understand? That's what we went over in the last class period. So you got to make sure that when you create a vector, you got to know if it's already empty or not, so that or know the size of it, so that you know if you wanted to do a pushback to add to it or pop back, or either to start from the beginning coming down. With vectors, we talked last time, it's like having a stack of papers on your desk. If I have 10 sheets of paper on my desk, and if I wanted to add to that vector or add to that stack, normally we would add to the top. But with the computer, it'll add it to the bottom. Every time we do a pushback, it's adding to the bottom of the stack, building the stack up, building the stack up. And then we would take away from the stack. When we do a pushback, a pop back, we taking away from the bottom of the stack. All right. So that's how vectors work. All right. And like I say, we had done a program with vectors. Let me see if I could open that program. And like I say, with vectors, and you gotta load the vector header file. All right. So it's some things you gotta know to do. All right. All right. So here, okay, so I got an error here. Let's see what happened there. It's just the vector one. Blah, blah, blah. And vector. This is what I have. And oh, I didn't even, okay. Yep, I have it declared. But then I have and vector ampersand. Let's see what I have here. Let me see what they really run. They probably won't. Oh, again, error. It's getting on my errors here. Let me see something. File, close this file. Open. Let me see, project, no project. I think it's this one that I did. All right, yeah. So here we got the vector, same names here. All right. Looking at this program, and what I showed you last time, you have a vector, and it's kind of, well, not set up the same way. Yeah, it is set up the same way, where you have a vector, two vectors. You read, well, is it two? Yep, two vectors. You're reading in the data in the one, all right? You're reading in the data into the other. You're writing out the data in one, and then you're writing out the data in the other. Kind of like the arrays, same thing, right? But notice with vectors, I didn't really have to pass a size, because our array, we have to know the size of our array, right? In vectors, there's a function that you could use called size, all right? And this size argument gives the length or elements that's in that vector. So we, rather than pass a value, which takes up time and space, we could just use the function to give us that value. So what happens is we created a vector. Now look at this. Just like arrays, this vector here is called what?
Number.
What this vector is called?
Number.
Number. How many elements in number?
10.
No, in number.
6.
Nope, you don't have any. See, it's no. We didn't specify, in the parentheses any size. See here? So that means what? In order to add to it, we're gonna have to do a what? A pushback, right? So that's vectors. I can have a empty or null vector, or look at this one. And then two, what type data is going into that vector?
Integer.
What? Integer. All right. So look at this one. What's the name of this vector? Right here? Num. What's the size of that vector? The number of elements?
10.
10. So now what that's saying is I've created an empty vector that has 10 elements, right? There's nothing assigned to those elements. So they all equal to 0. Everybody understand that? Now, if I do the same thing to number as I do the vector, a number as I do the num, and say add 10 element or add 10 records to them, or add 10 new elements, what would happen to the first one? It would start at what? If I add 10 elements to this one, to number, where would it start at? What position in the vector?
Like the 0?
0.
It'll start at 0, right? So I'll go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I had a vector that's declared as num and it has 10 elements, and I write and I add 10 elements to that vector, where it's gonna start at?
10.
10, 11, 12, 13, 14, 15, all the way to 19. You got what I'm saying? Because I already have 10. Whether they whether they blank or not, doesn't matter. I have 10 elements. And when I add to them, I'm adding to the bottom of that vector. So if I tried to, if I printed from 0 to 9 elements here, I will get whatever I inputted. If I printed 0 to 9 elements here and I did a pushback of 10 more elements, what I'm gonna get for num? Zeros. I'm gonna get zeros because what? I had 10 and then I added 10 more. So the first 10 is still what? Blank. Right? Right. You understand? So that's the things you gotta understand with vectors, where your starting point is or whatever. Because you can get very confused and say, well, oh well, I put the data in, but yeah, where was your starting point when you did it? If the vector was already declared to be 1,000, and you just added 10 to the bottom of 1,000, you could print 1 to 200, and you're still gonna get zeros, right? Until you get to that what? That 1,000 record on. Everybody understand that? So that's the difference in the two. All right. So if you look at this, and like I said, I just added, I just wrote it to where it can multiply a number. Now I did this example, but some of y'all tried to use this example in the assignment, where the assignment said to input from the keyboard, right? The assignment told you to input from the keyboard. So that was some instructions that I given, all right? So in this program, if I run this program, it's gonna do the 2, all right? And if I run this, all right. So notice what we did, we called this function, all right? The first one was num. What number? It took number starting at 0, all right? And x less than 10, and it did a pushback of the multiples of 3. Number was started at 0 and continued all the way to 9. But remember, when it called num already had 10 elements in it. So when we do a pushback on num, it's gonna add it to the end. And that's what I'm showing you. So see, you got to pretty much know where you are to know how to manipulate. So the thing was, if we was gonna manipulate number to the way we did, num, the way we did number, we would just use subscripts because our vector was already defined. All right. So that's what the key points in that assignment. All right. So any questions? Any questions? So let's look at
How was number given a value?
How is what now?
How is number given a value?
What you mean number where?
The variable.
How the values inputted? How did it know what to input into a number?
Yeah.
Because we did pushback. Here, look. Number dot pushback x times 3. So whatever x was, when x is 0, 3 times 0 is 0. So it's going to store 0 into the first.
Gotcha.
Right. Right. And then the next time it pushed back, x was 1. 1 times 3 is 3. So that's what it did. Right. Right. So that's how I knew. That's without having.
Thank you. I was confused on that for sure.
Yeah, without having the input from the keyboard. That's how I did it. Just to have it generate a number. Yeah. Yeah. And then, like I said, the size told it to do it up until that size. So the first one, when number was null, it created what? The first 10, and allowed you to output up until that. But the second one was already 10. We added 10, and when we printed, it printed from 0 to 10 plus 10. You see, and we got the 0, 0, 0, 0, 0, and then the last part. All right. Okay. Any other questions?
What does the dot size do exactly again?
It give you the number of elements.
Okay, gotcha.
Right. So that way, like when you're doing a loop and you want, like say, if you have 5 different vectors, right? And you want to manipulate a particular vector, you don't want to go beyond the size of that vector. You want to do just what's in the vector. So you can use that size function to say, like in here, start at 0, then do up a less than size. You know what I'm saying? So now I'm manipulating every element in my vector.
So basically, what you're saying is if that didn't have a size, then you wouldn't have to worry about the pushback. Is that what you're saying?
No, because pushback creates the size. This is the output. See, notice I don't have a size in here because if I'm adding, I'm not worrying about a size. See, the pushback adds on to the stack.
I understand now. I got you.
Right. The print, I want to manipulate it. So I might be going through this loop to add all the elements together and then print them. So I need to know what from the beginning to the end. You know what I'm saying? Just take if I had a college and I had my students' tuition amount in a vector. Now, how many students do I have every semester? It changes. So rather than having to write a program that actually have to do a count of all the records, I could just input the values into the vector and then use what to manipulate the tuition vector size. And I know I'm managing all of my tuition amounts. You got me? And the next semester, I could use the same program because whether I read them in, whatever the size is, it's going to use size. All right? Okay. Any other questions? Now, I don't want to go here. I'll go here. Okay, so let's go.
I do have one more question.
What you got?
So wouldn't it just be easier to use vectors then?
Right, but you understand what I'm saying? Now I'm gonna tell you. You say, okay, it's easy to use vectors. Some people love vectors, some people love arrays. Now, I would say it could depend on the project. You know what I'm saying? And how efficient you want to be or whatnot. But that's one of the key things. You're like, man, okay, rather than me using arrays now, I can use vectors because I don't want to have to create sizes.
Yeah, because you can store so many more elements.
And you're using the elements that you have rather than have to say, well, I'm gonna have a tuition. But I'm gonna have to make the size, say 10,000, because once I create it with an array, I can't add to it. You got what I'm saying? Right. Rather than with vectors, I can have just that size, and it's more efficient, right? So that's one of the questions that always come up. But if you understand the array concept, it's easy to go in and say, okay, all right, vectors, I get it, whatnot.
I guess depends on what program you're doing with. If you're dealing with a program with lots of different,
Correct. Oh yeah, and if you're dealing with wanting to manage resources, right. That's right. Now, class, look at this. Let's look at this program. Now, students' IDs ended with an odd number. This is the program you ought to do. Write a program that will find the average of 5 test scores for 15 different students. Now, this is the thing. The average scores must be stored into an array. Now, students ending, and like I said, it's going to be reversed. Students' ID ending with an even number. Write a program that will find the class average. And I'll show you what I'm talking about and after I finish reading it, of 15 test scores for 5 different tests. The class average must be stored into an integer array. Now, let's go to this. This is how the output should look. Student IDs ending with an odd number. You're gonna have a person name. Well, you're gonna have a heading: name, score 1, score 2, score 3, score 4, score 5, and then you're gonna have an average column. So what you're gonna do, you're gonna read in Bill. Then Bill gonna have what? 1, 2, 3, 4, 5 test scores. Right? Now, to find out the average, now this program is, I wouldn't say easier, but it's more, how would I say?
Detailed.
Understanding as we do averages for ourselves. So, Bill, to find the average of these numbers, we do what? Add them all together, right?
Add them all
right?
and divide them by the
And
total.
divide by 5, correct?
Yes.
Now, this is the thing though. I want you to read in all this data first. Then go back and calculate the average. I don't want you to read in the 5 scores, find the average, print it out, read the next one. No, I want you to read all this up, read the names into an array, then read the test scores into a 2-dimensional array. A 15 by 5 2-dimensional array. Huh?
I don't know what you're talking about.
Then once it's read in, then I want you to manipulate the arrays to calculate and print the average for each one of the, well, print out the scores and the average for each one of those.
Are you talking about columns and rows?
You could say columns and rows, which is right, but you're really
It's 2-dimensional arrays.
right. But in computer science, we always say rows and columns.
Gotcha.
Right, you got me? You always start off with row, whatever, column, whatever. All right. Now, looking at the other assignment, like I say, now your thinking is a little different. I want you to read in, same thing, reading all of these scores. Now what you're gonna do, you're gonna calculate the average for score 1 for all of the school students. Calculate the average for score 2 for all of the students. Calculate the average for score 3 for all of the students. Score 4 and score 5. Now, you might say, well, Ms. Vester, man, I don't really understand. This is hard, this is whatever. Let's go into our notes and look at 2-dimensional arrays. Look at what we talked about with arrays. And I'll tell you a trick that you can use, but like I said, you have to make sure your program is right in order for it to work. Let's go into the notes, all right? I'll leave that up. I'll go back to the notes again. All right, so let's get back to our notes. Go back to...
Do you mind publishing that assignment on Canvas?
Okay, all right, yeah, let's, I could go back. I think this is assignment. This is the assignment, okay. So go back here. Publish. Assignment 1, go back to
Is that worth canceling the instruction over? Could you just hold that question and let him finish his train of thought?
What happened now?
Nothing.
Oh, now, program 2. No, we need to do that one too. The program 2, well, we'll look at program 2 after also, because like you say, we don't get too caught up. Publish.
Got another class to
What, the little while?
Hmm?
Huh?
See, I have another class to go.
To go to?
Mhm.
All right. Let's see. Hold on. Let's go back to the notes. Let's go here. All right. So we go in the notes here, and we look at two-dimensional arrays. Let me move this to the side. All right. So we look at this. Okay, that's talking about how. That's some programs you could type up. Comparing two arrays, you have to compare each element. All right. Passing arrays. All right. And look, this program pretty much was in the book in a sense, but you got to put it together. Whatever. Right in here. All right. Two-dimensional arrays. All right. Look at here. And somebody said something about, I think Mr. Marler said something about columns and rows, but it's rows and columns, which is it. So a two-dimensional array is like several identical arrays put together. It is useful for storing multiple sets of data, right? Sometimes it becomes necessary to work with multiple sets of data. For example, in a grade averaging program, a teacher might record all of one student's test scores in an array of double, all right? But I did n. For each, even the average. If a teacher has 30 students, that means she'll need 30 arrays of double to record the scores for the entire class. But we're doing test scores, right? Now, instead of defining 30 individual arrays, however, it would be better to define a two-dimensional array, okay? One-dimensional arrays can only hold one set of data, all right? Now, two-dimensional arrays, 2D arrays, hold multiple sets of data, okay? Having what? Rows and columns. Not columns and rows, rows and columns. And see over here, it says the array has 3 rows, but it starts at what? 0, 0, sub-0, column 0. So the first score placed here would be in position score sub-0, sub-0, all right? Then the next one would be score sub-0, sub-1, score sub-0, sub-2, score sub-0, sub-3. So 3 rows, 4 columns. You're gonna have 15 rows and 5 columns, right? So because you're gonna have scores, test scores, and then the student names and then test scores. Right. Now, it tells us in defining a two-dimensional array, you're gonna have 2 size declarators. So you're gonna have the row, not the column, the row first, and then the column, all right? So this right here, 3 by 4, 0 to 2, and then 0 to 3, all right? Row and column, all right. So when processing the data in a two-dimensional array, each element has 2 subscripts, one for its row and another one for its column. Now, question, just an open question. If I'm gonna manipulate a two-dimensional array, how would you think I have to do that when it pertains to loops? Anybody?
You have to still edit them via the individual element.
Okay, but in reference to loops, how if I'm dealing with a two-dimensional array, how would I pretty much have to deal with it?
Jacob said element by element. That's what Jacob said.
Yes, but I'm looking for something else. Begin with an N.
N.
My loops need to be
nested.
Wow, there you go. Because remember, I don't know if when we took the class, when we talked about loops, and I had an outer loop and an inner loop.
Yeah.
Yeah, you remember how that worked?
Yeah, I had to set some of the code for it. I do.
Right. Because so if I had an outer loop that went from 0 to less than 5, and I had an inner loop that went from 0 less than 4, I had to do what? Start at 0 and 0, and then when I fell into the loop, I went what? 0, 1, 2, 3, 4, 0, 1, 2, 3, and then went back out and went to 1, and then fell back in what? 0, 1, 2, 3, fell out again, and went to 2, and then what? 0, 1, 2, 3. So you see what's happening?
Yeah.
The outer loop would reference the row, and the inner loop would reference the what? The column. So when I'm at row 0, then I fall into the nested loop. Then I can go across sub 0 through whatever. Everybody got that?
Yes, sir.
So if I wanted to read my 5 records, I mean my 5 test scores for my 15 students, what would be the max for my outer loop and the max for my inner loop? When I'm reading the scores.
It'd be 15 for the outer, 5 for the inner.
Right. So you understand what I'm saying? Start at 0, 1, 2, 3, 0, 0, 1, 2, 3, 4, 1, 0, 1, 2, 3, 4, 2, 0, 1, 2, 3, 4. So what happens when I'm at 0 on that first row, then I'm gonna read 0 sub 0, 0 sub 1, 0 sub 2, 0 sub 3, and then 0 sub 4. Then I kick out, it kicks out the loop, go to row 2, row 1, then 1 sub 0, 1 sub 1, 1 sub 2, 1 sub 3, 1 sub 4, kick on out. So and they're gonna repeat till I get to that 15, or less than 15, and I'm kicking out. Everybody understand that? So that allows my data to be stored into my my array. Now, once the data is stored into the array, now you need to manipulate it. But this is one thing we didn't talk about, parallel arrays, because you're gonna have a name and then you're gonna have test scores, correct? Name, test scores. So you're gonna have to have an array for the names. Now the name's gonna be like a one-dimensional array because you're gonna read in what? A string array, sub 0, sub 1, sub 2, sub 3, sub 4, sub 5, sub 6, all the way to 14. But you're gonna read in a name, sub 0, then you're gonna read in score sub 0 through 4. You got me? Read in name, and then the next name, then score sub 0 through sub 4. So what happens is, you got to understand your logic, okay? And what I'll try to do is try to create a blank. Where I'm at.
I think Mr. Sylvester, how much time do you have left?
I know, like I say, I don't have no time left.
If you gotta go, you gotta go. Stop asking him what time he's got left.
Yeah, cause I'll just go on. What I'm gonna do, I'll create a blank one, and wizard. And now, what happens here? What I'll do, I'll show you somewhat how the loop would work. All right. So what happens is, and you're gonna be reading. I think you're reading this from a data file. So that's another issue we got to talk about, because I think you did a program, but I might do something Thursday. All right. So normally, and like I say, all right. So if I had something like, if I wanted to read the data or whatever, I'd have something like, and I could just do, I'll just do a for loop. It won't be exact, but I'll do something like for int x equals 0, x less than the 15, x plus plus. All right. So
Wouldn't it be 14 because of if you did 15, you'd be adding an extra value.
No, but I'm doing less than. You got what I'm saying? 15 is not equal to 15.
Got it.
Right, okay. All right. So normally what I'll do, I always put my curly braces, all right? And I'm gonna show you why. Check this out, this inner loop, for int x, well, I'll do y. Y equals, because you can't do the same one because you're gonna run into issues, equals 0, or y less, and see, there's gonna be some issues to you. You're using the x and y, not understanding what's what else. Less than 5, y plus plus. Now, and then look, so you see how the curly braces all of a sudden become very, very important? Because, man, you could run into issues. Now, look at this. At this point, and I'm going to show you, and I'm not really doing it. Say if I had something like in data, and I didn't do an input file, and I had somewhere up here, I had string, and I don't have my string defined at the top. String name 15, all right? And you know I'd have to have string up here, but all right, so now, but then I have to declare that. But I'm saying, if I do in data, all right, so what happens here? I've fallen into this loop, X is 0, so it's gonna read names of 0, so X stayed at 0. But then I fall into the loop, and now I can do in data, what it is, if I did something like score, but now watch what happens. Watch what the common error. If I had score as integer, I would have to say score sub what? What would I put here?
Sub 0.
But I'm trying to use my variables.
So it'd be score y? No.
You see that? And see it's X. See what I'm saying? So you're staying on that same row, which is what? 0, right? Out here, that outer loop. Remember? That outer loop is 0. Because you don't do column and row in computer science. We do row, right? And then column. So we'll do sub X, what I'm doing, sub Y. So what? When X is 0, I'm gonna do Y sub 0. But I'm gonna stay in this loop. When X is 0, then I'm gonna do Y sub 1. X is 0, do Y sub 2. X is 0, do Y sub 3. X sub 0, do Y sub 4. Kick on out. X becomes what? 1. Read name sub 1. Then what? Y starts all over again. So I'm at 1 sub 0, 1 sub 1, 1 sub 2, 1 sub 3, 1 sub 4. Kick out, go back, X becomes 2. So you see what's happening? That's how the nested loops work. Everybody understand that?
Yes, sir.
Sure.
All right, so that's how you would read in the data. Now, for those of you who have to calculate the average of the student, you don't have to do pretty much nothing to change anything. Because when you're manipulating your array, you're going to basically, you don't need the name really, right? All you need is another array, a single array called average, and what? You're going to read in all these scores and add them to a accumulated value. Then you kick out the loop, that loop, and then you what? Calculate the average, and then you put it into that average array. Then you do the next one. Then you calculate the average, put it in the average array, and then once you get to 15, 15 to 5, and you get to the end, you finish. And all you got to do now, write your nested loop to what? Output your name, your scores, 0, 1, 2, 3, 4, and then your average sub 0, name sub 1, average 1 sub 0, 1, 2, 3, 4. Well, yeah, right? And then average sub 1, and on and on and on. Now, this is the trick that I was telling you about the getting the average of each score. you're gonna, the people who have to do that, they're gonna read the data in the exact same way as the other program, the students did the other program. The difference gonna come in when you gonna calculate your information. What you're gonna do is you're just gonna simply reverse this. No, not here. That stays the same. You're gonna reverse this. This gonna be you're gonna go from Y to X. You understand? So you're gonna take your outer loop, your inner loop, and make it your outer loop, and your outer loop and make it your inner loop. Now what that's gonna do, you're gonna say what? Column 0 to row 15, get the average. Then column 1, 0 to 15, get the average. Then column 2, 0 to 15, get the average. Then column 3, 0 to 15, get the average. Then once you do that, then you can go back to the original way, print out the data, and then print out your average your array. So it's a little trick in between. All right. So what I want you to do, I want you to work on it. But what I might do, because I think I might have to, on Thursday at 10 o'clock, I'll probably we're gonna have a session and we'll talk about it, go through something, whatever. If you got something written down, we could look at it and go through the program to see, where you are. But hopefully you've started working on it. You at least got your data written in and you can write it out and you can print it out. Because this data should be coming from, and I don't know if I have it. I'm trying to see if I have my screen. I think I got it coming. You're pulling it from a data file. Let's see here. I think that's what it's supposed to be doing. At the Word document. I don't want to go there. I want to go to the other one. I think you're pulling it from a data file. That's program 2. All right, let's see. All right. Okay, you got a header file, no replace or whatever. Okay, let's look at this program because I didn't read through the whole program. All right. All right. So here it says you ought to have 3 separate arrays. All right. And no matter how you print out the data, you're going to have 3. You're going to have the name array. You're going to have the scores array, which is going to be a 2-dimensional array. And then those of you who doing the student average, you're going to have a 15-element array for the averages that's going to be in a column. Those of you who doing the scores array going to have a 5-element array to store in the scores and then print it out. All right. Now, I want you to read the data from an input file called get underscore, and JD is the initials. Like if I was to do it, it would be get underscore DS for David Sylvester, your first initial, last initial. Your calculation array where you actually calculate your average, I want you to use a calc array called calc, and then your initials. Now, the thing is, remember, we should know how to pass what? An entire array, because we did that in the previous program, right? So we should be able to what? Write our argument list. Okay, what I want to pass. When I'm doing my computations, I don't need to pass the name array. I need to pass what? My scores array, and my average array. Because my average is what I'm calculating. My scores is where I'm getting the values to calculate. But when I do my output function, now I need to pass my name array, my scores array, and my average array. Now, it won't cause any problems if you pass more arguments than you need, but you're just wasting resources. All right. So just keep that in account. But like I said, when you output this data, you're going to output your heading. Then you're going to have a loop to output name sub, what I'm just saying, name sub 0, then score sub 0 sub 0, 0 sub 1, 0 sub 2, 0 sub 3, 0 sub 4, and then average sub 0. Then name sub 1, score sub 1 sub 0, 1 sub 1, 1 sub 2, 1 sub 3, 1 sub 4, and average sub 1. And and on and on. The folks down here, you're gonna be printing out your heading. You're gonna be printing out name sub 0, score sub 0, score sub 1. Score sub 0 0, score sub 0 1, score sub 0 2, score sub 0 3, score sub 0 4. All right, and on and on and on. Name sub 14, and then score sub 14 sub 0, 14 sub 1, 14 sub 2, 14 sub 3, 14 sub 4. Then you're gonna print out the label average, and then average sub 0, average sub 1, average sub 2, average sub 3, average sub 4. All right, so that's how you're gonna output the data. But what if I was you, I would work on the program in sections, okay? I need to create my data file. Go ahead and create your data file. Name, score space, score space, score space, score space, score space, score. 5 scores for every name. Make sure you have that correct, because if your data file not correct, you could get data all jumbled up and still not read it in all together. So I would do that first, create my data file, then I would create a program, my C++ program, and I would start off doing my data file and creating my function. Did I tell you to read from a data file? Read from get. You create my get function to read my data, all right? So now I read it, and when I'm reading it, I might want to print it out just to see. I always can remove my cout statement, but I want to make sure I'm reading it in. And once I read it in, okay, I got that. Then I'll move on to creating my function to calculate my average, all right? So then see if I'm doing my nested loop to calculate my average, all right? Because like I say, you gotta know how that average goes. Like I say, the ones who doing the average across, you're straight. The one who doing the average down, you gotta flip the loops. You gotta go from 15 to 5 rather than 5. Well, you gotta go from 5 to 15 rather than 15 to 5. I'm talking about the inner and outer loops, all right? So, and then if you get that and you get that working, you can always print your average just to see if your averages are coming out right. But then now your output results, it should look like this. So then you'll work on that. So I would just say work on it in stages rather than try to write one big large program with all these 3 different functions, and this ain't matching with this, and this ain't doing whatever, and you're like, man, I don't know where, what, how. Just work on it in little small stages and get something accomplished where you can know, hey, I got this. Now I'm gonna move on to the next step, rather than try to write something totally big and then get lost. All right. So I'd say get started on that one. Now the second one is just a program. Let's see what I did on that one. And then you got your documentation. We could talk about that Thursday. The second program, now it says to write a program that will declare 2 vectors, one event and one of double. Using a loop, prompt the user to input the quantity and cost of 8 items. All right. The quantity should be stored into the integer vector, and the cost should be stored into a float or double vector. Within a function, all right? So the only function you're using is to print, all right? Within a function, print the quantity, cost, and total cost of items on hand, all right? Total cost of items must be calculated. So you're not gonna just say, okay, this 30 point whatever. No, you're gonna read in this, then calculate that. Read in this, read in that, calculate that. All right. So that's what this program does. So you're not really putting this in a vector. You calculating it and printing it at that time. All right. So you're gonna read in those values. All right, that's gonna be read in here, but then you're gonna write a function to output that data that you read into that vector. All right. All dollar amounts should be displayed with 2 decimal places. So make sure you use what? IOMAN IP and make sure you get the right data representation fixed and show point and fixed. All right. So that's that program. It's a little smaller, less whatever, but it kind of working with the vectors, kind of letting you get to a little feel of vectors. All right. Any questions? Questions? Ms. Bradford, I see you.
It just got to register. I'm just
Yeah, like I say, man, how would I say? 192 is like, okay, well, we're getting into it. This is this, whatever. And a lot of times we can work with you, help you with that. 193 is a little more, okay, this is what we're doing. Hey, you kind of like loosening the rein, okay? You got to learn this, you got to learn that. This class is almost like, okay, you know this, we went over this, you know this from this class, now we taking this, you got to be able to build on it. Because see, when you get in Java is like pretty much totally online. It was like information is put down, do it. Because you know programming, you know whatever, you should have that concept, you should be able to do it. So it's like kind of slowly weaning you to say, okay, I got this problem, I got to tackle it, I go in at it, I can do it, whatever. I'm going to research, I'll do whatever, I'll get it. But like I said, I'm going to try to work with you because I know time, and a lot of times you have a lot of questions or whatever. So Thursday, we'll meet again Thursday at 10 o'clock? At 10 o'clock. And like I said, questions, I can go over whatever, show you whatever, and whatnot. All right? Okay. To kind of keep y'all going. So if you see somebody, well, I could just post it that we'll meet on Thursday, and that'll cover it for anybody who didn't come. And I'll post this lecture also on in the list. All right, because if you notice in Canvas, I just have it to where I'll just post it in there and you'll see it in the list. All right, so I'll just keep adding it to the playlist. All right. Okay. So any questions? Any other questions? Like I say, it's gonna be tough, but then you got to work. Got to do some work. You got to put in some work. Because really, I didn't really kind of go through the chapter itself. I went over trying to make you understand the information here and whatnot. Yeah.
Cool. Sounds good. Is that it for today's sessions?
Yeah, that's it. So if there's no questions, wait for this to finish recording and post it. Because I have a 12 o'clock class. So so get started. Sometimes it's good to just jump on it and get started as soon as possible. Sometimes it's good to just wait, say, okay, but I don't wait too long. Don't wait 2 or 3 days. All right? But I'll catch y'all on Thursday.
Yes, sir.
Right?
Have a good day.
All right, y'all too.
Day, sir.
All right. Let's see where I'm at. Okay.